So this is our example 3. We have to find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. So our polynomial is x square minus 3. So this we can factorize using the identity a square minus b square, which is equal to a plus b into a minus b. Okay, now using this we can write x square minus 3 is equal to x plus, so 3 we can write it as root 3, x plus root 3 into x minus root 3. So these are the factors of the given polynomial. So when we equate this to 0, we are getting either x plus root 3 is equal to 0 or x minus root 3 is equal to 0. So here x is equal to minus root 3 or x is equal to root 3. So these are the two possible values for x. So here our alpha will be is equal to minus root 3 and beta is equal to root 3. Now we have to verify the relationship between zeros of the zeros and the coefficients. So we know that the sum of the zeros is equal to, what are the some zeros? Minus root 3 and root 3. So minus root 3 plus root 3, which is equal to 0, and which is also equal to, what about the minus b by a? Here there is no b term, so we can take b is equal to 0 and a is equal to 1, so which is also equal to minus b by a, or we can say minus of coefficient of x divided by coefficient of x square. So that's verified. Now product of the zeros. Product of the zeros, we can multiply minus root 3 with root 3. So this will become minus 3. So the product of the zeros, we are getting minus 3. So this we can also write it as c by a. So here c we have minus 3 and a we have 1. So c by a we are getting constant by the coefficient of x square. So we verified both the cases, sum of the zeros and the product of the zeros. So I hope this is clear. Now moving further, this is our example 4. We have to find a quadratic polynomial, the sum and the product of whose zeros are minus 3 and 2 respectively. So here the difference is that the polynomial is not given. We have to find the polynomial, but the sum of the zeros and the product of the zeros are given. Now let's just write. Let's just assume that the quadratic, we are giving the standard form. Let the quadratic polynomial be ax square plus bx plus c is equal to 0. Sorry, quadratic polynomial, it doesn't, only quadratic equations will have equal to 0. So ax square plus bx plus c, this is our quadratic polynomial. Now here the zeros can be, the zeros are alpha and beta. So these are the two zeros possible. So we have the sum of the zeros, that is alpha plus beta, is equal to what is given. The sum is given as minus 3 and the product is 2. So alpha plus beta is equal to minus 3 by 1. And the product, that is alpha into beta, is given as 2 by 1. So this is equal to the constant by coefficient of x square, and here it is minus of coefficient of x divided by coefficient of x square. So we got the coefficient of x or b as 3 and a as 1. Here we got c is equal to 2. Okay, so we got a, b and c. Now we can form the quadratic polynomial. So x square plus 3x plus 2 is the required polynomial. Is a required polynomial. Also, we can multiply this particular equation with any number, then also we will get a similar polynomials. We can take any other real numbers and multiply with this one. Then also, for example, 2x square plus 6x plus 4 is also the required polynomial. So different number of polynomials are possible, which we are multiplying this base equation, base polynomial. So this is the required polynomial and this is also correct. Okay. Now moving to the next one, we have in example 5, we have to verify 3 minus 1 and minus 1 by 3 are the zeros of the cubic polynomial. Okay, so a polynomial is given and we have to also verify the relationship between the zeros and the coefficients. So we know that the standard form is ax cube plus bx square plus cx plus d. This is our standard form of the cubic polynomial. So from this, a is equal to 3. Here p of x is given in the question as 3x cube minus 5x square minus 11x minus 3. So that means a is equal to 3, b is equal to minus 5, c is equal to minus 11 and d is equal to minus 3. So that means now we can check for the relationship. Now we need to verify also that 3 minus 1 and minus 1 by 3 are the zeros of the cubic polynomial. If these numbers are the zeros, then their p of k will be equal to 0. So that's what we are going to check now. So we are going to check for p of 3 and p of minus 1 and p of minus 1 by 3. So p of 3 is equal to, we have to put 3 in the place of x. So 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3. So this is 3 into 27 minus 5 into 9 minus 33 minus 3. So this is 81 minus 45 minus 33 minus 3. So when we add all these and put the minus sign, what we are getting? We are getting, so 45, 33 and 3. So 81 we are getting. So 81 minus 81, it is equal to 0. So P of 3 we got 0, so it is a 0 of the polynomial. Now next P of minus 1 we have to check. P of minus 1 is equal to 3 into minus 1 the whole cube minus 5 into minus 1 the whole square minus 11 into minus 1 minus 3. So this is minus 3 minus 5 plus 11 minus 3. So this again we will get as 0. Now the next one is P of minus 1 by 3. So P of minus 1 by 3, we have 3 into minus 1 by 3 the whole cube minus 5 into minus 1 by 3 the whole square minus 11 into minus 1 by 3 minus 3. Okay, so this we will get minus 1 by 9. This we will get minus 5 by 9 and plus 11 by 3 minus 3. So when we expand this and cross multiply, we will get 0 in the end. So this is also a 0 of the polynomial. So 3 minus 1 and minus 1 by 3 are the zeros of the polynomial. Now using this we can verify the zeros. So the sum of the zeros, that is alpha plus beta plus gamma, is equal to 3 plus minus 1 plus minus 1 by 3, which, okay, 3 minus 1 it's 2, 2 plus minus 1 by 3. So it will become 5 by 3. So this, now this 5 by 3 we can write it as minus of minus 5 by 3. Why I am writing like this? Because we have minus of coefficient of x square divided by coefficient of x cube. Now we have alpha into beta plus beta into gamma plus gamma into alpha. So this will be equal to, now 3 into minus 1 plus minus 1 into minus 1 by 3 plus minus 1 by 3 into 3. So this on expanding, what we will get? On expanding we will get minus 11 by 3. So this is, what is the equation for a cubic polynomial? What is the equation for a cubic polynomial? It is c by a, where c is the coefficient of x and a is the coefficient of x cube. So here c is minus 11 we are getting. Now the next one is alpha into beta into gamma. So for that we have 3 into minus 1 into minus 1 by 3. So this 3 and 3 get cancelled, minus 1 into minus 1 it's plus 1. So 1 we are getting. So that's d by a. So minus d by a it is, so we have to look. It is actually minus d by a. So how can we write it? Here d is minus 3. So we can write this as minus of minus 3 by 3. This will again become 1 only. So this is minus d by a, and here minus 11 by 3. Here we have our c as 11. So c by a is correct. C is minus 11. So c by a is also correct. Now also for minus b by a, is also correct. So we have verified for the relationship between the zeros of the polynomial and the coefficients. So here first what we have to do is we have to verify the zeros by using p of x, and we got all the verification as 0, so it's the 0 of the polynomial. It satisfies the condition that p of k is equal to 0. So then we can easily verify using the formulas. Now next is exercise 2.2. We have to find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Now the first one is x square minus 2x minus 8. So that's our first one. Now this we need a product of minus 8 and a sum of minus 2. So what can be the factors? 4, minus 4 and 2 can be a factor. So I am writing it as x square minus 4x plus 2x minus 8. Now this again x into x minus 4 plus 2 into x minus 4 is what we are getting. Now this will become x plus 2 into x minus 4. Now here the value of x square minus 2x minus 8 is 0 if x plus 2 is equal to 0 or x minus 4 is equal to 0. So either x plus 2 is equal to 0 or x minus 4 is equal to 0. So here we getting x equal to minus 2 or x equal to 4. So these are the two values we are getting. Okay, so the question was to find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So now we got alpha and beta. So alpha is equal to minus 2 and beta is equal to 4. So alpha plus beta is equal to minus 2 plus 4, which is equal to 2 by 1. Now here minus b is minus 2, minus of minus 2, so it's same as 2, and a is 1. So we can write this as is equal to minus of minus 2 by 1, which is also equal to minus b by a. So first condition is verified. Now alpha into beta we are getting minus 2 into 4. So that we have minus 2 into 4 is minus 8 by 1. So that is same as C by A. So that is also verified. So our first sub question is verified. Now for the second one. So for the second one, it's 4s square minus 4s plus 1. So 4s square minus 4s plus 1. So that's our second sub question. This was our first sub question. Now this we need a product of 4 and a sum or a difference as minus 4. So we need a product of 4 and a sum as 4. So that is only possible with the one factor, which is 2 and 2. So this we can write it as equal to 4s square minus 2s minus 2s plus 1. Now this is 2s into 2s minus 1, and here again minus 1 into 2s minus 1. This will become 2s minus 1 into 2s minus 1 Now if 4s square minus 4s plus 1 is equal to 0, so either 2s minus 1 equal to 0 or 2s minus 1 equal to 0. So both we are getting s equal to 1 by 2. So both values we are getting s equal to 1 by 2. So these are the zeros of the polynomial. Now alpha is equal to 1 by 2 and beta is equal to 1 by 2. In that case, alpha plus beta, what we are getting? 1 by 2 plus 1 by 2, which is 2 by 2. Or we can say 1, which is same as here if you are taking minus b by a, which is minus of minus 4 by 4. We are getting the same. We are getting the same as 1. So this is equal to minus b by a. So first condition is verified. Now alpha into beta, that is 1 by 2 into 1 by 2. So that we are getting 1 by 4, which is same as c by a, which is same as c by a. So this condition is also verified. The constant term divided by the coefficient of s square. I hope this is clear. Now moving to the third one,